Hi everyone, my name is Emil Hodzik-Santor. I'm a master's student for Dr. Michael Freilich at the University of Toronto, and today I'm going to be giving a 5-minute crash course on stopping rules in randomized control trials. Now, before we go into the details, stopping rules tell us when to stop enrolling participants in our clinical trial. We would stop enrolling participants when there's no longer any justification to expose them to the risks of continuing the trial. Most often, a trial will be stopped for one of the following 3 reasons. First, for harm. We've already found that the treatment is harmful to the subjects in the trial, and we conclude that they should not continue to be exposed to the risks that the treatment pose. Next, for benefit or efficacy. From the interim data, we've already seen that the treatment is superior to the control or the standard of care in the trial. Third, for futility. From our interim data, we see that we're unlikely to ever reach a satisfying conclusion to our trial. Even if we enroll many more participants, at the end of the trial we're unlikely to reject any hypothesis and reach a conclusion. A systematic review estimated that approximately 18% of trials are stopped early. 6% of these are due to a recruitment failure, but about 12% are due to a stopping rule. If you break that down further, about 5 to 6% are due to harm or safety reasons, less than 1% for benefit or efficacy reasons, and about 5 to 6% for futility reasons. If you're designing a clinical trial, it's good practice to predefine or pre-specify a stopping rule. A stopping rule is going to be specific to your trial and often involves going through the following steps to determine what the rule should look like. Number 1, the number of interim analyses. 2, the timing of these analyses. 3, an interim p-value. And finally, specifying the stopping rule for harm, for benefit, or for utility. To start, it's important to determine the number and timing of interim analyses that you're going to conduct. At these interim analyses, that's when you decide whether or not to continue or stop the trial. The common rule you'd hear is that simpler is better, with fewer analyses and major benchmarks. Something like just 1 interim analysis at 50% enrollment, or alternatively, if you're doing 2 interim analyses, 1/3 and 2/3 enrollment. With more interim analyses, we increase the probability of reaching a type 1 error or a false positive. We adjust for this by choosing a lower interim p-value, which you might do with something called an alpha spending function, which spends some of our pre-specified alpha level, maybe 0.05, at each of these analyses. We do have a video on the channel about p-values that you can check out. There are 3 methods for determining an interim p-value that you're likely to encounter. If you look at this chart on the right, on the y-axis, you see the interim p-value that's going to be used, and on the x-axis, you see the interim analyses from the first interim analysis all the way to the final analysis. The Pocock approach, which is this straight line, uses a constant reduced p-value for every analysis. The second approach that you might see is the Habital-Peto approach, which starts like the Pocock method with a constant reduced p-value. That's up until the final analysis, where it uses the initially chosen threshold. The third method is the O'Brien-Fleming alpha spending function, which spends increasing amounts of the final analysis p-value. At the start, you see a very small p-value, a very strict threshold, and the red line curves down, getting closer and closer to the final analysis p-value. When it comes to specifying our stopping rule, this is different for each type of trial and each type of outcome. The simplest I find is for a superiority trial with binary or continuous data. That's when you're dealing with an outcome rate, like a rate of death or a patient's blood pressure, which can be compared and tested against the interim p-values we determined. This becomes a little more complicated when we're dealing with time to event data, which uses hazard ratios to assess our outcome instead. We have to compare the observed hazard ratio, calculate a confidence interval with the interim significance threshold, and then compare that to our baseline hazard ratio that we're looking at. Then, when we're dealing with adverse events, we would be comparing those to an unacceptable rate, which might be predetermined by a research ethics board. What I find to be most complex would be dealing with stopping rules in non-inferiority trials. In these, an O'Brien-Fleming spending function cannot be used, and secondly, non-inferiority margins further complicate the data analysis of every type of outcome, whether it be binary, continuous, or time to event. I won't get into these too much, but there is another video on the channel about interpreting non-inferiority results, another quick 5-minute crash course. Before we wrap up, I want to go over a few points that might be interesting to you if you're designing your own clinical trial and have to specify your own stopping rules. The first is to caution when stopping for benefit. A recent systematic review found that trials that stop early for benefit often overestimate the study effect size, especially when the number of events is small. And although I mentioned that the rate of trials that stop for benefit is less than 1%, the systematic review found that those results are becoming more and more frequent as time goes on. Two other points that you might want to look into are some other methods for interim analyses. The first would be using Bayesian methods, which take an initial event rate and the observed data to estimate a distribution and then assess that for harm, benefit, or futility instead. The second would be using conditional power, which estimates the probability of reaching a conclusion at one or many interim analyses. This method is often used in non-inferiority trials to make the results a bit easier to understand. Thanks very much. I hope you learned something in the video, and I hope you check out some of the other videos on our channel.